get started. And in today's class, we are going to talk about error handling. How do we do error handling in C++? And most of the concepts that we are going to learn today, you have already studied in Java. It is going to be more like, okay. And I would also like to understand in this class, if we really understand why we need exceptions. For handling errors, why do we need exceptions? This is also one of the very high-level topics that we are going to discuss in this class. So we are just starting from the code that we have like last week, the matrix. So maybe before proceeding, I remember I just went over this really fast. I'll just review of whatever we saw about templates. We created a matrix class, which is like a 2D, two-dimensional array, and we can store. We have data which is like a vector of vectors of type t. We didn't want this to be of type integers or type doubles. We didn't want to restrict that to any particular type, but we wanted to make this matrix generic. We wanted to store a matrix of any type of object, and so we have a type t. And to have any class templated, the definition of the class should have this particular keyword called template, and whatever is the type of the class. So this T is the data type that you're going to use inside the matrix. So you use the T here. This can be anything. This particular T, you can just even name, this is just a name. You can just have it as type, and then you can name wherever you have used T, you can just have it as type. This is just a name, but most of the places in real world code you will see this variable T, because people easily can relate to, okay, then this is a template type, okay? And there is this keyword called type name, and in C++, you can, most of the places you will see type name for what is the type that this class is going to contain, but some people also tend to use class. This is also acceptable in C++. It says like T is that type, but still this is so confusing. Personally for me, this is so confusing to me, because like whenever we have something like class here, I get confused with are we like defining a class or something like that, and so I personally don't use this, but you will see this when you are reading other people's code, you will see this also. This is also valid, the valid keyword for defining the type of template. It doesn't make sense to me because this T can be an object. In that way, it's okay. This can be a class. This keyword can be a class, but this same T can also be of primitive types like integers, doubles. In that is the thing that confuses me, and so I personally prefer to use type name, but you can feel free to use anything, but I would suggest you to use type name. Yeah. And we have this matrix, and wherever you had that, so this operator, this array subscripting operator, returns a reference to a vector of t. Initially it was vector of ints, but now since it is made generic, now this becomes vector of t. And we had the constructor, and in all these places, and very similar to that, in all the member functions, you have this particular thing, template type name t. Okay, and then now this print says this is a print function inside the class matrix of t. So now when you create a matrix of integers in the main function, this particular a new class will be generated. So since this is a template, you should think of it like this is not the actual class itself. Even though we have it as a class, this is a templated class. Whenever someone uses like a matrix of int, at that time the compiler will actually generate a class named matrix of int or matrix of double. And at that time, this T will be substituted with whatever type that we have there. Okay, and we saw the definition of the array subscripting operator, the print, and yeah, two constructors. And in main, we had like very simple code. We had like a matrix of integers called m, matrix of double called n, and we just initialized the first element 0, 0 in both these matrices. And now, if we try to print this, you can see that the first matrix prints 3000, second matrix prints 2.3000. So with the same matrix class, we have created two different types of matrices. One is a matrix of int, and another is a matrix of double. Okay. Any questions about templates? And we should also remember that whenever we are writing templates, all the code should come inside. You see here, the interface for the class is here, and also the implementation of the class is right within the same file. Yeah.
Let's say we're adding two matrices together and we want to template it. Does the matrix have that we're passing in, does that need to have the type like defined as well? Or is it just like assumed?
So if we are defining a member function for adding two matrices?
Yeah.
Okay, the question is, if we are defining a member function for adding two matrices, I think we will do that right now. Do we need to add the template keyword T, okay, in the matrix that is coming in from the right hand side, right, as the argument? Can someone answer this? Maybe I will just explain the question like in code here. That's a very good question. So the question is, we are having, assume we are defining the addition operator for this matrix. We are going to say operator plus, and this is going to take in the right hand side matrix with a const as a const reference. And this is going to return a const matrix. We should go and see like why are we returning a const matrix in the addition operator in the complex numbers. We discussed why do we need to do this last class, okay? And yeah, so if you see here, can someone tell me like now this is the question like this, should this matrix be templated, right? Yes or not? Yeah?
Yeah, because you couldn't add two matrices of different types.
Yes, very good. So it should be templated because whenever you create a matrix of integers, you can only like add matrices of integers. And so this should be of type T, and also the returning matrix should also be of type T. Then it take care of all the other things. So now we have this, okay, this is a very good place to start whatever we are going to learn today. So we have this operator plus, okay, addition operator for matrix. And now let's go and define let's just define this particular method, okay? Now we have a matrix and we are just going to add stuff inside this matrix. So what we can do is first, okay, this particular operator plus will be called in a way like if we are adding two matrices m and n, we are going to say m plus n, right? And in that case it will be m dot add of n. So just for simplicity, I'm making both these matrices to be int matrices, and I'm having like 3 and 2 as the first elements. Now our task is to actually create another matrix of type int where it says like m add, and we are just going to add these two matrices m plus n. Right now this is not possible because we have not defined this addition operator yet. Now we are going to do that, okay? So and then we are just going to print that matrix m add dot print. This is what we are going to do. So I'm going here. So in this particular thing, so we have a left hand side, right hand side. Left hand side of addition operator, right hand side of addition operator. Left hand side is usually this object. And so first what I'm going to do here is like just create a matrix of the template this here. Then we are going to create a left hand side matrix here, create LHS, and I'm just copying this whatever this is pointing to, which is the current object. I'm just making that particular matrix to be a left hand side matrix. This is just a local variable within this operator plus. And then what we are going to do is like we know that when we are adding two matrices, we need to like do it like element by element. And for doing that, and I'm just going to, now I'm just assuming that maybe both these matrices have the same dimensions, okay? And so we can just take some variables like in row, like rows, RHS dot rows, and then I'm just making a columns variable, cost is equal to right hand side dot rows. This can be anything, this can be on anything, this can be on left hand side or right hand side, because as of now we are assuming that these two matrices have the same number of rows, number of columns. And now when we do like matrix addition, this is going to go through all the rows, and then this is we are going to write another for loop which is going to go through all the columns, And then inside this we are just going to say, we want to create a result matrix also, okay? Because that's where we are going to collect the result. So I'm going to say matrix of T. This is the result matrix. And this is going to be created with num rows to be this rows and the num rows to be the columns to be the whatever columns that we have here. So we have this particular thing. Okay. Till now I think this is straightforward, right? Whatever we're doing, we're just like creating a temporary matrix, and then here inside this we're just going to say result of I and j equals left hand side of I and j plus right hand side of I and j. Okay? So just adding these two things. But that is red color, like this has been underlined, saying that there is an error. Okay? Can someone say like what is the problem here? So this particular right hand side matrix, we are saying like this particular code is saying we cannot subscript that particular right hand side with that array subscripting operator. Any ideas why this is a problem? So if we look at how this matrix comes in as an argument, it comes in through a const reference, okay? We are saying like, okay, we will not modify this right hand side using this RHS, this matrix using this const reference, and we should not. But this, applying this RHS of I, what it does is it just calls the operator, right? The array subscripting operator, which calls this operator. But look at that. This does not return a const reference. The array subscripting operator that we have returned actually returns a non-const reference. So what is happening here? If we are trying to use this will be a non-const reference. But we have made a promise here that using this RHS, nothing inside that matrix RHS will be changed. Because it's a const reference, or actually we cannot change it, the compiler will not allow us to change it. But here, even though we are not changing it, because we are only using it on the right hand side to just add those two things, but the compiler is not so intelligent enough to understand that okay, we are not actually changing it, because there is a possibility that by some chance you can just like add some code here which says like RHS of ij equals 0, something like this. You can just do something like this. You can just zero out all the elements before adding it, and some crappy thing. So since something like this can happen, usually now we are not able to access the RHS using this array subscripting operator. Okay, and how can we solve this? It's like very simple. Usually and if we just add a const here, const keyword here, there is an issue. If we just add a const keyword here, then it means that this array subscripting operator will only return, okay, this data of index, the one-dimensional vector, by a reference. If it returns only by a const reference, so the way to like overcome this is just to add a const here, okay? You can just say const this particular thing. But what happens is if we do this, then this code that we have here, okay? This code that we have here, where we actually want to use the array subscripting operator to change something inside that particular matrix, will not work. Does this make sense? If we just make it const, then this code will not work. And so, usually, the array subscripting operator, whenever you are overloading the array subscripting operator, you need to have two versions of the same. So the two versions are, you just copy the same code again, and then the other version is this will return by a const reference, and this is also a const function. It will also not change this object. So this is the other overloaded version. And this type of overloading, so we have seen like function overloading, the same function can take different number of arguments or different types of arguments. Then we saw operator overloading, where we can define meaning for operators for our own classes, like addition operator, subtraction, multiplication. And this particular thing, whatever we just saw now, having the same array subscripting operator, overloading of the array subscripting operator function, with two different versions. One is a non-const version and the other is a const version. And in the const version, we just return const here and we say like this is a const function. It's not going to modify the the object in any way. This object in any way. And this particular overloading is called const overloading. So these two functions are exactly the same except the constness. So this overloading is called const overloading, and these are now considered as two separate functions. Now, whenever you go and use the array subscripting operator, you should add like now you should add interface also for this. So in the interface, this should be actually first step, okay, and then you should come there for the definition. Yeah. So you just do this. You just do a const here. The return type is like a by const reference, and this member function is const. And understanding constness is so important for understanding like what is for reading and writing C++ code. And now if we see here, once we added that, now this right hand side is accessible. In the sense now we can access this inside this particular using this const reference. Using this const reference. And are we missing something else here? This particular member function, with respect to constness, can someone say, are we missing something else here? Or is this correct? This is good enough. So this member function, addition, just takes in this and the right hand side and just adds those two things and then returns a matrix, right? So this should also be a const member function. This should not actually modify this parameter, this object in any way. Yeah.
Wouldn't you want it to not return a const matrix so that if you wanted to add to it again, you could do it again? Because if you return a const matrix, wouldn't you not be able to add to it again?
So do you remember like why we added const? So the reason for having this const here is like after having a return type of const matrix, you cannot have addition on the left hand side of the assignment operator. You cannot have something like m plus n is equal to p or something like this. Else this particular statement would be syntactically correct in your code. You want to disallow that.
Well, that's the const that's in the parentheses, isn't it?
No. So if we take the return type const, okay, if you remove this return type const, then what will happen is this statement is a valid statement having something like m plus n is equal to, let's say p is another matrix, m plus n is equal to p. This is a valid statement. But now this will not be possible because whatever this m plus n has returned, that matrix is a const matrix. Now you cannot change that matrix with any other, by assigning with any other matrix. And so to disallow this particular thing, we are having the return type as const.
Okay, so then after you do say you did p equals m plus n, could you later do something equals p plus something because it was const?
So if I understand your question correctly, so it's a question like let's say m add, okay? It's a question like m add is equal to m plus p, m plus n plus p or something. Are you asking this? Adding p matrices?
That would kind of work too, yeah.
Yeah. This is possible because again, this will return a const matrix, okay? But again, that const matrix will, that particular const matrix will call dot add operator plus of p. So in any ways, we are assuring that the operator plus is not going to change this object, right? So we can call that on a const matrix. Yes, it is possible.
Okay, and then later, on a different line, you can add to it again?
Yes, you can definitely do it. So, okay, that
So
constness will be valid only for that particular line.
Okay,
So,
that's right.
okay, that constness, whatever we are talking here, will be valid only for this particular line. And then you can go and add more stuff to it later. Okay. Okay, so now we have this. We should also add a const in the definition. And we have not returned, we forgot to return the result, so we have to return the result here. The result matrix, which is a matrix of type T. So can you see this? The first matrix is 3, 0, 0, 0. We are just changing the first element in the matrix, and yeah, this matrix becomes 5, 0, 0, assuming the other things are working properly. So now we are able to like add two matrices. Now, with respect to correctness of this particular function, now let's talk about what are the issues with this particular function. So this works for the normal case, assuming everything is correct. This works. What are the issues with this particular function? We are not checking if the matrices are of the same size. That's a very good thing. So now let's assume by mistake we are creating, or like by purpose we are doing something like this. We are creating a matrix of size 2, 2, and then we are creating a matrix of size 3, 2, and then inside that, how can we detect that an error has happened, because we cannot add two matrices which have like different dimensions, right? So how can we detect that, and how can we make the program like fail at that point? Anyone? So the way we can do that, in C++ we have a statement called assert. Okay, in assert we can just make sure that assert just makes sure that okay, this particular condition should be valid at this particular point. So here, even before we do anything, okay, you get this, okay, and after this, before assigning rows and columns to be one of these things, first thing that we can check here is to just say assert, and we know that the left hand side's rows should be equal to the right hand side's rows, and for assert you need to include a thing called cassert or assert.h. In C++ we usually include cassert. This is the header file that we include to use assert. Okay, cassert. And once you have this, now you can just say, I'm just asserting if the rows are equal, and at the same time, I'm also asserting if the columns are equal. And what this statement says is like, okay, for the program to proceed after this particular line 76, this statement should be true. If this statement is false, then the program is going to crash right here. Okay? So now when we try running this again, so can you see this here? It tries to create that matrix with 2 rows and 2 columns and 3 rows and 2 columns, and then you can see like when we are trying to add it, it immediately says assertion failed. This particular condition is not met. Okay. And if we are giving it the correct matrix, then it will just pass that particular assertion, but there will be nothing that will be printed here. Once it passes that particular assertion, then it just goes to the next line and continues as usual. Okay, this is one way. But what if in the same place, what if we don't want to crash our program right there, but want to proceed after that? Okay, we cannot add two matrices. Just print a error message saying like the dimensions are mismatched or something like this, and then just proceed with your program in a way like I want to, after this, even though if I'm not able to add two matrices, it's okay. I just want to, let's say, go to this place. Okay, I want to print this in, or assume that there's some code happening here. Okay, how can we do this with the current code? Anyone?
Verify?
Pardon?
Verify?
Verify?
Yeah. No.
Can you explain like what does that do? I don't know. I'm not like aware about that.
No, I just remember assert like it kills it terminates the program. There must be another like unit testing you can do
Okay.
besides assert.
So assert like actually kills the program, and so in this case, what are some ideas that you can come up with? So we have to proceed and we have to come to this particular place. Even though if this thing fails, we have to at least come and print this end here. Okay.
Have to throw an exception.
So this, yes.
We can use like a try catch equivalent of Java and C++.
Yeah, very similar. Yeah. So here in this particular place, it's very difficult to like handle this error because you cannot return some dummy or like some dummy matrix from that function, because whatever matrix you may return, that may be an actual matrix that may be returned from an addition. You understand? If you just return a matrix of all zeros, that could be a valid matrix after adding like two matrices of -1s and 1s. So you cannot like return any dummy matrix in this case. Here you cannot return any dummy matrix, but instead what we can do here is like now we can use C++ exception handling feature. It's very similar to how we do it in Java. So I'm just commenting out this particular cert right now. Okay. So now after the condition that we are checking is, just copying this condition. So if just changing this to, if the rows are not equal or if the columns are not equal, then immediately throw an exception here. Okay, in C++. You can just use the same keyword throw. You can throw an exception here, and you can throw in Java. If you remember, you can throw only like objects of some particular class which are derived from the exception class. Right? The exception would be the parent class. You can like throw some objects of the derived class. In C++ also you can do that. That's also preferred, but also it provides you the opportunities to throw any primitive types also. You can just throw an integer, you can just throw a string. So we can just, here in this place to start with, we're just creating a string called, like, let's say error, and we just initialize it with dimensions mismatch, okay? And then I can just throw this error from here. So now this is such a, if you guys really don't understand exception handling, try to like listen right now, because it's such a wonderful feature in any programming language like Java and C++. Because here this matrix, we have a contract saying like this will always return a matrix of T, a const matrix of T. But with exception handling, we are completely having a different alternative path here, which says that okay, when there is an error, I take a totally different path and I throw something which is very similar to returning from this particular matrix, but we are throwing this string. And in main, what we can do is like we know that this particular thing is going to fail. When this addition happens, it's going to throw. Let's just run it as it is right now with different dimensions. 2, 2, and 3, 3. You see here, we just created these two matrices. The printing is like not in the correct order, but actually if you can see here, terminating with uncaught exception of some type string. Okay, says like the program has terminated with uncaught exception, and the reason for this is like the exception when it is thrown, it will go up in the hierarchy from to the function that it actually who called this particular function till it reaches main. And in main, if you are still not handling this exception, it will actually throw. And how do we handle these exceptions? We know that addition is the thing that is causing this, so we just put a try. All these things are like very similar, and then you say like once this try just means that this particular piece of code can throw an exception, and if it throws, catch that particular exception here. And we know that the exception that we are actually throwing is a string exception, so we are just catching that string by reference, since we need not make a copy here of that particular string again. And so we're catching the string by exception, sorry, by reference, and then we are just saying see out, just print that yes. Now when we run this, if you see here, the two matrices were printed, and then when we were trying to add it, it just told dimensions mismatch, and at the end we went to the, it just program resumed execution after that particular catch block. So exception handling is very similar to how we do in Java, but there are some differences, like we can even throw integers, we can even throw strings, but you cannot do that in Java. You have to throw an object of type some exception class which is derived from the actual exception. Okay, and even in C++, we can also do the same thing in a way like we can actually create our own user-defined exception classes. So let's try to do this right now. Instead of just throwing a string here, now we are going to create a user-defined exception class. Let's say dimensions mismatch. This is just to show you how to create user-defined exception classes and no other purpose, because in this particular case, just throwing a exception of type yes is okay. So maybe we need not do it for this particular thing since we already have this, but let's see. Okay, with this particular exception handling, how many of you think that this code is okay? In the sense this code looks good, or if there's any issues, are there any issues in this code? Okay, I do think it's okay. And okay, let's now talk about the constructor. We have this constructor, this parameterized constructor for our matrix. Okay. Does this code is there any bugs in this particular code, or will this code work in all situations? Yeah.
Should make sure that it's positive where it's.
Yeah. So we should make sure inside this constructor we cannot create a matrix of negative dimensions. We cannot create matrices of like say -1 rows and -2 columns. And currently if we do that, okay, currently if we try to do that, let's say we are creating a matrix of -2, -2. When we run this, immediately there is an exception thrown. It says terminating with uncaught exception of type length error from the vector. Now can someone guess, like we have not thrown anything from the constructor, but still we are getting this unhandled exception error message. Do you know why this happens? Yeah.
When you do the parentheses or the brackets, you're trying to call on like the spot -2, and that doesn't exist, or 0.
Yeah. So when we call this particular constructor, the matrix constructor is called. You go inside this constructor and you call a method on a vector. Data is just a vector. You call a method on a vector called resize. Okay. And this resize takes in some rows. And now you send in -2. When you send -2 to a member function of vector, it checks that particular thing, because vectors you cannot create a vector of size 2, of size -2. So this condition is checked there, and this member function of vector, the resize, now throws the exception. Okay, we are not throwing it explicitly. This throws the exception. And since we are not handling that particular exception inside the matrix constructor, the same exception is actually thrown again to the calling function, which is the main. And so, even though we don't have an explicit throw here, this is what is happening. But now what we are going to do is, we are going to write our user-defined exception class, which says like negative dimension or something like that. Negative dimension exception or something like that, and then we can throw that particular thing here whenever the matrix gets a negative dimension. And to do that, what we do is like just create a class called, let's say, negative dimension. And now, even in C++, all the exception classes that we create should be subclasses or child of the parent class. The parent class is called std exception. Okay, and it is defined in a header file called exception. That's it. So this is very similar how we do in Java. We just derive from the parent class called exception, and then it will be just exception with a capital E. But here it is like std exception in the standard library. You just create this particular class, and inside this particular class, first let's just go and look at this exception class in the standard library. So they say like, okay, this is the actual exception class, which is the parent class, and then they have like different types here. One is like the logic error, another is like runtime error, and many other stuff. And it has constructor, destructor. We'll go into these things in the next few classes. And then it has some operator overloading of the equals operator. And then there is some member function called what. Okay, there's a member function called what, which is a virtual function. And in whatever, so you just go inside this what, it just says it's a virtual const char star what const. So now, if you don't know C, don't worry about what const char star represents. The const char star is the C way of saying that this what, the member function, this function named what is going to return a string. It's just a string in C. Okay, the const char star is just a string in C. And so since these were developed like very long ago, they did not use strings here. They were using the C equivalent of the string. So this particular highlighted thing is just a string in C, and we will understand this in the next class because we are learning pointers there. Okay. And so now whenever you create your own class, you have to override this particular member function called what. It just means what is this exception. It just prints some explanatory message, returns the explanatory string. So I just copy this particular thing, and you have to like actually define this here. Okay, you have to say what is this what going to return. You can just return a string directly. You can say negative dimension exception. So we are returning a string, and this is the representation of string in C. And let's try. And there is one more thing that's missing here. Okay, we'll come to it when we see that error. And now inside the matrix constructor, initially you can just check if the rows and the columns are non-negative. If R is less than 0. Or if C is less than 0, then immediately throw. Now we are going to throw the object of our particular user-defined exception class, which is the negative dimension. Okay, you can just take negative dimension exception also, that's fine. You just throw this particular thing. And when you go here, whenever you create whenever you create a matrix, so we know that here there's going to be a problem, right? So we just say try this particular thing, and we can just catch, and the exception that is being thrown is negative dimension exception. Just catch it by reference so that we need not copy it, and just you can inside here you can just say std cout the e dot what. Okay, so when you actually catch it by reference, okay, I'm not sure like why it's not showing the what dimension. So yeah, you just catch the negative dimension exception and try printing that what, and then it's done, okay. And when we try to run this, I think there will be an error here. It says the exception specification of overriding function is more lax than the base version, and they also show how the base version is. In the base version, there is a keyword called no except, and this no except keyword in C++ just means that this particular function called what will actually not throw any exceptions. We are just guaranteeing that this function will not actually throw any exceptions. And so whenever we are defining this, you have to have this keyword here, okay? But usually people don't have this particular keyword, no except. Okay, let's just try running this. So since we did not say explicitly that what is a public member function, it thinks that by default everything is inside a class is private, so it thinks that it's a private member function, and so we have to have the public keyword here. Now when we try to run this, okay, so now that's the issue here in a way, like, okay, since this matrix matrix is inside this trie, okay? Since this matrix M is inside this trie block, that only goes inside that particular scope. It will not be visible anywhere outside that particular thing, okay? And so to avoid this, usually when you write, error handling code, it will be like a single try block and there will be different catch blocks after that. So I'm just going to change it to that particular way. So I'm just going to change this code inside the try and even this particular code inside the same try. But I'm just going to say, okay, now that particular thing can be a catch block and there can be some other catch blocks also. So if you catch exception of negative dimension, then do this. If you catch exception of type string, then just do this, okay? And so now everything comes under the same scope. So now if you can see here, okay, all the code that we wrote is inside the try. So now this line may throw an exception of type negative dimension, which we have as a user-defined exception, and this particular line can throw an exception of like dimensions mismatch, which is just a string exception, and we are catching these three exceptions like below here. Okay. Yeah. So now if you see here, the negative dimension exception was thrown, and immediately from here directly the control would have come to line 18. And if you see here, whatever we had inside that method called what, which just is like an informative method which tells us what this particular exception is about, that particular message is printed here because we explicitly call the what member function here, and then it's done. It just comes here and prints the end. So inside this, instead of having this underscore no except, okay, usually you will see the keyword like throw. Initially this was like very confusing for me because like in Java if you have like throws or something at the end of the member function, it means that that particular function will actually throw an exception, right? Which actually throw an exception of some particular type, but that particular feature is not there in C++. You cannot say like, okay, this function will throw these exceptions. And to have that particular like what to say, a simulation of that particular feature, in C++ we have this throw, okay, and inside you can say like, let's say exception 1, exception 2, you can specify all these exceptions here. This particular member function will throw all these exceptions. But if you don't have anything specified like this, it is very similar to that no except keyword, which means that this particular member function will actually not throw any exception again, okay. This throw here is like counterintuitive because here this means in C++ the throw at the end means this particular member function what, which is actually a function of exception class, will not throw any exception. So now if you try to run this, you should get the same thing. Yeah, you get the same thing, negative dimension exception. Any questions about this till now? Can someone tell me like why do we even use exceptions if we can use like error codes? Like let's assume a function like factorial, okay? If we can just return error codes from the function, if the input that you're getting inside the factorial function is a non-negative number, okay? You want to just return an error code. Why is the approach of, why would you prefer exceptions over just simple error codes and having like if-else conditions to check the error codes? Have you guys thought about this before? Okay, they introduce us something like, okay, we have exceptions and you can use these things, okay, it's cool. In case like the matrix that we just saw, it would make sense. But in simple cases like factorial and things like that, can you think of any use case for this? Just even in factorial, just think about what happens if even if you have the return type as a long, okay? What happens if the input that you're giving goes above like a number like 20 or 21? Yeah?
This might not be exactly what we're looking for, but I think it's more useful to people who might use your code later. Like if they use your library or whatever, and they just get like a number back, that doesn't mean anything to them. Whereas like if you return them a message, that's much more useful information.
This is definitely a good point. So if we are like creating a library like vector, and if it throws like just error message like -1, okay, we would really not understand what that even means. But if we see here, when we use the resize with the negative number, it throwed like a message saying like there is a length error in the vector. That was like much more useful for us to go and figure out what. That was a very good point. One more thing that I can show you, because like people may definitely ask you when you are working, if you are suggesting them to use exceptions, they will say like, okay, why not just use simple error codes with if condition checks and stuff like that. So I'll just show you some presentation for the same, for you to like go and defend yourself like why this may be useful. Okay. So let's take, this is the case how your code will look like. Okay. If we just use error codes, if you see here, this function f just returns some return code, and if the return code is 0, it means that the function has succeeded, and else it means that the function has failed. Okay, and this particular type of code, you can see it in so many places, and this is not bad. You should understand that this is not bad code for this particular code snippet. This is actually very good in the sense, okay, we get 0 if the function f succeeded, else we get some other value. And this is even how our main function works. The main function returns 0 to the operating system process that is actually invoking the main. Okay, and whenever that process gets, the program that calls main gets the return value of 0, it understands that the program has completed successfully. Okay, else for any other return value, it understands that it fails, it has failed for some reason. And then the same code, if you just convert it to exception handling code, this is how your code will look like. Try of this particular function and catch, you just catch that particular exception, and this is how you catch exceptions of like any type. In the sense, in Java, if you want to catch any type of exception, you say like the exception class name and like object name, right? Here in C++, again you use the base class version, and you should have it by reference. Okay. And this is how you do it. But if you see the number of lines of code for this simple example, and this is like handling errors with exception, it's almost the same. So people will tell you, show you some piece of code like this, and ask you like, okay, why would you even choose like using exceptions? But this will not be easily seen in small like 4-line code snippets like this. But when you go to real world code, the code sample code may look like f1 calls f2, f2 calls f3, and f3 calls f4. Okay, there are some functions here. And f4 is like a very low level function which actually where some error happens, and this particular error is detected here, and this particular error is handled only at f1. Okay, if this is the case, then if you do it with the normal return code like strategy, this is how your code looks like. F1 calls f2, and you check like if the return code is 0, then do something, else do something. Then in f2, again you have the same logic there. You will have the logic for checking the return code, and that logic should be correct. Okay, and the same happens in f3 also. So the logic is just like f3 calls f4 here. Okay, f4 is where the actual error condition is detected and some non-zero error value is returned. And if you see here, the same check happens in all the places from f4. Where the actual, this is the only place where the error is detected, but here also you have to make the check, here also you have to make the check, and here again this is the actual place which needs that particular check. Okay, so your code becomes like this, and this is just 4 functions, but in real world you can think of this like at least like 20 functions. When an error detection may happen like at least 20 levels deep from the main. Okay, and so this code duplication of checking the error happens at each and every intermediate function if you use like return codes. But the same thing with exceptions looks like this. F1 calls F2, F2 calls F3, F3 calls F4. You need not worry about anything here, about any error checking here, because F4 will throw that exception, and if you don't handle that in F3, it will throw it back to the function that called it, which is F2, and if you don't handle that in F2, it will throw it again back to F1, and in F1, so now you have to have a try and a catch there for some particular exception that you want. So look at the code. The code will be minimized so much when we use like exception handling, and it's also definitely a good practice. But in some companies, so for example, Google has some code that has been written long ago, where at that time exception handling was not even introduced. Okay, and to maintain that particular code, if they use And along with the particular code, if they add like exception handling with the new code, then what will happen? The old code will break. Okay, the legacy code will break. Just for this purpose, what they are doing is like they are completely ignoring exception handling. So if you are going and working at Google, I'm sorry, this particular class will not be useful for you at all because you will not be using exception handling in C++. But in many other like places and in research labs, exception handling will be used in whatever we are doing. Okay, and this is one very good example of like why you need exception handling. Look at the size of code here, just for 4 functions, and look at the size of code here for the same 4 functions. Okay, this is just like even a skeleton. Okay, I think that's it, guys. So yeah, we're done with exception handling, and for next class we're going to talk about pointers. I'm actually very surprised to have this class, like till now, this is like the 11th lecture, I think lecture 10, 11th lecture. Till now we did not like introduce pointers, but after introducing pointers, everything is going to change, okay? So be prepared. I mean in C++ we are going to see like, I just remember Thoreau's quote about like, rather than love, money and fame, do me truth, right? So from tomorrow you will be actually seeing the truth of whatever is inside. See you guys.